All right, so we are going to resolve an initial condition. So we're given what is called a differential equation because we're dealing with the differentials. And we are asked to resolve y of 0 equals pi. In other words, the point 0 comma pi is on my original function. Okay, so that being said, first thing we do is multiply both sides by dx. So dy equals 1 over 16 minus x squared dx. And now I can integrate both sides. So the integral of 1 dy becomes y equals. And then what is my format here? So when we compare and look, we end up that we're messing with arc sign. So I've got a u squared, a u, and a du. And I've got an a squared and an a. So my u squared is x squared. My u is x. My du is dx, which means I need no balancing because I got everything I need. This is going to be a 16 and that's a 4. So when I integrate this, this becomes the arc sine of u over a plus c. So I have x over 4 plus capital C. So that is my general form of the equation. Well, I need to evaluate this at 0 comma pi. So if I evaluate y is pi, and then the arc sine of 0 over 4 will become 0 plus c. Well, what this is asking is where does sine have a ratio of 0? Sine has a ratio of 0 at 0, so this is a 0 term. So my c value must be pi. So my specific equation that addresses the initial condition is y equals the arc sine of x over 4 plus pi. Okay, and then the last one we have, I want to find the area of the region, and the shaded in part takes you from a negative pi over 2 to a pi over 2. So I'm going to integrate from a negative pi over 2 to a positive pi over 2. And just for conversation's purposes, because of the symmetry here, you could go from 0 to pi over 2 and then double your answer. Or you could go from negative pi over 2 to 0 and double your answer. It doesn't really matter. You'll get the same thing. All right, so I've got a 3 cosine x over a 1 plus sine squared x. Oops, 1 plus sine squared x dx. And so what I notice is that the derivative of the bottom is 2 sine x cosine x, which is not what's in the top. So I'm betting that this is going to be heading us towards arctangent. And so I want to see what I've got. So make your little chart thing. So what's your u squared? It's sine squared. So what's the derivative of sine? I'm sorry, what is, if u squared is sine squared, what is u? It is sine. And now what's the derivative of sine? It's cosine x dx. And then your a squared is 1 and your a is 1. So 3 is just coming along for the ride. Okay? So when I integrate this, I get 3 coming along for the ride of the arc sine of u, which is sine, over a, which is 1. And then I am going to evaluate from a negative pi over 2 to a positive pi over 2. Okay, so this becomes 3. The sine of pi over 2 is 1. And then where does arc sine have a ratio of 1? It has a ratio of 1 at pi over 2. So because arc sine and sine undo each other, this is just going to pop out. So I've got 3 times pi over 2 minus 3 times, and then the exact same thing is going to happen. As long as these limits of integration are in the original domain for arc sine, you can use them. Okay, so that becomes another 3 pi over 2, and it's negative, sorry. So that becomes 3 halves of a pi plus 3 halves of a pi is going to be how many halves of a pi? Is going to be 6 halves of a pi, which is 3 pi. So that is your final answer for that problem. And that is it for this section.